Welcome back to the second part of the rope tutorial. In the second part of the tutorial we will be building the player character and player controller to interact with the ropes, so the player can jump to the ropes, attach himself and move from the left to the right or from the top to the bottom. In the first part of the tutorial we built the rope mechanics, so if you didn't watch that is necessary for this part of the tutorial, go and watch that first. The basic plan for this tutorial will be to create a normal kinematic body to the player. Then we attach an area 2D to the character to detect if the rope is touched. If a rope is touched, the player character is attached to this rope and updates his position according to the rope piece. We also apply some physics to the rope parts to make it look a bit more interesting. So let's go and let's start with this tutorial. I start by adding a new kinematic body 2D and a collision shape. And I won't go into every little detail in this process because there are plenty of tutorials out there on how to create a player character using a kinematic body 2D. So I'm just setting up the basics, and now I'm using a polygon 2D node to just quickly create some shape to have something to work with and to not look so boring. I'll quickly throw in an animation player and create a new animation for walking, which is basically just wobbling back and forth, but it will be good enough for this use case. And I also create an idle animation by scaling it a little bit up and down. I also add some scale to the walk animation to make it more interesting. I also made a jump animation, but in the end you'll see I won't end up using it because it would be just too much hassle and somehow it didn't work out, so you can happily ignore this part. Now let's save the scene and create a new script, and then we start going into more detail. The first steps I'll do now are covered in pretty much every Godot tutorial so far about kinematic body 2Ds. I define a gravity constant and a velocity vector 2 that I will use for movement. The gravity constant is then multiplied by the delta and added onto the velocity's y-axis on each physics frame. Then I write one line of code that I can't remember why I wrote it. And finally I used move and slide with the velocity and give the parameter of vector up, so the kinematic body 2D knows where the floor is. As you can see, gravity seems to work perfectly, but the idle animation wasn't set to start automatically, so let's do that. Back in the script, I also want to increase the gravity as it was a bit too slow. Now everything seems to work, and let's continue with our script. The next thing I'll do is to implement left and right movement. To do so, I'll check if the input UI left and UI right is pressed and add a new constant called walk speed that will tell the player how fast he can walk left and right. If you press left, the walk speed gets subtracted, and if you press right, the walk speed gets added to the velocity's x-axis. And if you don't press anything at all, the velocity is set to 0, so the player stops. Now let's give the player the ability to jump, otherwise it will be very hard to reach those ropes. To do so, I added another bool variable called jumping. So if the action UI up was just pressed and you aren't jumping at the moment, the jump velocity is added to the y-axis of the velocity. I created a new constant called jump power, and then I just set the velocity's y-axis to this jump power. This will only happen once, as we ask for is action just pressed and not is action pressed, otherwise we will go to the sky. Anyway, the jump power was much too high, so let's reduce that a little bit and also increase the gravity. That should look much better. Now let's add the animations next. To start, I get a variable called anim, which is a reference to my animation player, and I use that to play the walk and the idle animations. I also want the player to face the direction of movement, so I take the x parameter of the scale parameter and put it to -1 or 1. I later found out that it doesn't work that way because I already set the scale parameter in the animation player. So a little bit later you will see how I fix this. I'll also get a reference to the polygon 2D because I need to scale the polygon and not the whole scene. I also only want to play the idle animation if the player is not jumping. Now let's start with the necessary steps to make the player attachable to the rope. Let's add an area 2D and call it rope detector. As always, we also need to add a collision shape 2D and we set the shape to a circle. Now I move the shape to the position of the hand, so it will basically detect when the hand touches the rope. Don't forget to set up the collision mask and layer. Now we need to connect the body entered signal to the script. I also need to set up a new variable called hanging. To check if everything works, I'll start with a simple print. And my plan is also to make the rope piece into a class named rope piece. I'll also quickly head into my rope scene and change the class there because I use it in the add piece function. And back into my player script, I can now filter the argument of the rope detector body entered signal to only accept rope piece classes. So I don't have to check if it's really a rope piece or something else. As you can see in the print command, everything works fine. I get the rope piece that the player touches as an argument from the signal. Now I want to disable the gravity when the player is attached to the rope. I do so by setting the hanging variable to true when the signal hits, and with the changes that I do in the physics process function, I will disable the gravity if the player is hanging from the rope. And now it's also a good time to change the variable name of jumping to can jump. It just makes more sense and makes it easier to read. So let's do the quick change to the script. And if we test our game now, you can see the gravity is disabled when the player touches the rope. The only thing that's missing now is to attach the player to the rope and to update the position of the player character. To do so, I'll take everything of the normal movement script part and move it into the part where the player is not hanging. So when the player is not hanging, movement works like we already set it up. To find out where to put the player and how to update the position, we need to know the position of the rope piece. To do that, we have an easy option. We save the parent, the rope scene, into every rope piece instance. By doing so, we have access to the rope parts array from the player script. First, let's get the ID of the attached rope piece. The ID is also saved in the rope piece, so that's an easy thing. Let's create a new variable called attached rope part ID, where we will save the rope part that the player is attached to. I also create another variable called attached rope. In this variable we will save the rope that the rope piece is part of, so the rope where the player is attached to. Now let's take care about rope movement. To start, I copied the part from above where the player can press left and right for walking, and I just delete the part where we walk. When the UI left action is pressed, the attached rope part ID is reduced by 1. I need to clamp the value between 0 and the size of the rope pieces array. I do the same for the other direction. I'll just add 1 instead of subtracting 1, so I go into the other direction. Now I created a new function called getPlayerPosition on rope, and there I'll calculate the new position of the player. Let's call this new function whenever the player moves left or right, and let's see if it works. It looks good on the first sight, But if you look closely, you can see that the player position is not updated when the rope moves. This is easily fixed by just calling the function in the physics process while the player is hanging. Now it looks much better. The player moves very fast on the rope, so the next step to do is to somehow make this slower. To do so, we need to interpolate a position between two rope pieces. So let's make a new variable called rope section progress, and we will increase or decrease the value of this variable when moving left and right. Now we have to change the code a bit, so instead of directly skipping the rope ID, we increase or decrease the rope section progress. If the rope section progress is smaller than 0, we decrease the attached rope part ID by 1, and if the rope section progress is bigger than 1, we increase the part ID. So basically, when the rope section progress is over 1, we want to go to the next section, and the same in the other direction. I'll add this line here to reset the progress if the player attaches to the rope, and we do a little quick print to see what's happening if we test it in a second. You can see that the printed progress looks good, so let's finish the code. And it will be very simple to achieve the final result. We just need the position of the current rope section, the position of the next rope section, and we'll then do a linear interpolate, and we use the rope section progress for that. To use a linear interpolate in Godot, you can just use the lerp function that is supplied by the engine. So far it's looking good, it's smoothly moving across the rope. We'll just have one little bug to fix, and that is this. So let's change some code here. We only want to increase or reset the rope section progress if the rope part ID is bigger than 0. If it's smaller than 0, we don't want to reset it, so we don't overskip basically on the last part. Into the other direction, we only want to reset the rope section progress if we are not on the last piece of the rope. Let's give it a quick test run with the new changes, and this is not what we were looking for. At that point I really needed to clean up some old code and fix some other bugs, and then it finally worked. Another thing I wanted to introduce was the option to let go of the rope and to jump off from the rope. So we add two more actions, UI down and UI up, and I basically just copied a normal jump from up above, and we use that inside the hanging section of the physics process. So now we can jump and let go of the rope. There are a couple of more things that we need to do. First, so far what we did only works if the rope is spawned in one direction. So we have to check if the rope was started at the left side and going to the right side, or if it's the other way around. We do so in the rope script by just checking which X position is smaller, and like this we can just say if the rope is going to the left or not. And if it's going in the other way, we just swap around the input actions, and it's a bit cheap, but it works, so that will be fine. So here I'm adding one more variable that I can use here to change the actions, and if it's going to the other direction, we'll just swap that around, and like this we can go from left to right and from right to left with the same buttons. The next step will be necessary to make the rope look a bit more natural. Right now it doesn't really react to the player and it looks like the player waits nothing. So our next step will be to inform the rope about the active rope piece that we're attached to. So I set up a new setGet function called setActiveRopeID, and if this function is called, I will change the mass of the rope section that we're attached to. We do so by just looping through our array of rope pieces and find the rope piece that we're attached to by using the information that we got from the player. So let's make a new loop and loop through the rope parts, and first we want to reset the mass of all the parts, and if the part is the part that the player is attached to, then we will set the mass to a bigger value. So that will have the effect that the rope is dragged down when the player is attached to it. As we need to compare the ID that we got sent with this function, we have to change this a bit around to get the ID of the for loop iteration. Now let's write one more function to leave the rope so we don't have to use the same code over and over again. And by setting the active rope ID to -inf, it will reset the mass of all rope segments. So if the player leaves the rope, everything will be as before. I really want to see an effect when the player is attaching to the rope. So to do that, I make a new variable called lastPos, where I save the last position. When the player is then attaching himself to the rope, I use apply central impulse on the rope piece with last position minus position and multiply it by the power of the impulse. One more thing I really wanted to add is the check that the player is not attaching to the rope if he's on the floor or if the player is pressing up. So let's put that here, and like this we can stop the player from attaching to the rope if he is pressing the jump button or if he's on the floor. Now I also want the player to let loose of the rope if he is on the floor. We're just having one problem. The function is on floor is only working if we move the body with move and slide. And we move the body by just changing the position. So we have to add 2 raycasts to check if the player is on the floor. When you use raycasts, never forget to enable them. They are disabled by default. So we also set the right collision mask for them and add them to the left and the right of the player collision box. Then inside the player script, we can write a custom floor check function that just checks if the 2 raycasts collide or not. While I was at it, I also added a reference to the rope detector and a reference to the 2 raycasts, because we'll call them quite often, and then it's better to not always use node-get. It will save a bit of performance, but it wouldn't even matter in this scenario. In the floor check function, we will just return the right ray and the left ray is colliding function. So if one of the rays is colliding, it will return true, meaning the player is on the floor. Let's test this now and see if the player lets loose of the rope. It's looking good. At this point, we have most of the functionality done and everything's working. The player can attach and detach from the rope. So basically you can close the video now. Everything that you will see from now on is just me polishing stuff and adding more animations, just messing around with the things, because you know that I can't just leave stuff like it is. So let's just look what we can do. First thing you can see me do is adding another polygon 2D, basically adding a second frame to the player animation. So we will have one frame, we can call it, one polygon 2D that is basically the walking shape, and one shape for being attached to the rope. So we messed stuff up and changed things here and there. And at that point I realized that the changing of the looking direction of the player didn't even work. And that was because the animation player was using the scale property, so the scale property that we set in the script was completely ignored. To fix that, I went into the track settings of the animation player, and you can just write colon and use another property. For example, if we animate the scale property, we can also write scale colon y to only change the y property of the scale, so we can still change the x property inside the code. Now I'm also adding a new animation for the player hanging on the rope. It's just the player swinging from the left and the right to sell the effect a bit more. In the player script I make some changes to use the new hang animation. To do that, I added a setGet function to the hanging variable, and there I set to either play the idle animation or the hang animation. Now everything works as we intended it from the start. He plays the hang animation, everything looks good, so now everything that's left to do is to add some detail to the scene, add a sky background, and yeah, just add some little things here and there to make it look a bit cooler. We also add a little part to the player, I like to call it the rope attacher, so it looks like the player has something in his hand and attaches himself to the rope. I paint some more props for the scenery, like some icicles, to build my own really cool version of bottomless. And to finish the bottomless look off, the guy of course needs a backpack. So let's add that. There I found one more problem. If the player changes direction, it looks really strange as the attached point jumps around, and it looks really strange. So my solution for that was to just move the rope attacher part to the exact center of the scene. So when the player changes direction, you don't really see it. I had to change some animations here and there to make it work, but in the end I think it looks really cool and it doesn't look strange when the player changes direction. At that point I also realized that it's really problematic to just change the X scale of the polygon 2D, so I added one more node 2D node where I put all the visual nodes inside and I can flip the X scale of that node and everything works fine. Now I'm just changing some visual parts of the map to make it look a bit more cool, and then we're done. That's it for today. I know the tutorial was at times a bit chaotic. I promise I'll take more care next time. I still hope you enjoyed it, and if you did, consider subscribing to the channel. And yeah, see you soon. And I promise it's not gonna be such a long time until the next video. And have a good time. Bye!